books was in. The books are in. Yep. They in. They're here.
Log in to KofiPaisaTV.com and get Spears of the Mossy Volume 1 by Kofi Paisa Research Team, from Spears the Pen Volume 2 by Kofi Paisa Research Team, Spiritual Combat Volume 3 by Kofi Paisa Research Team, One Night Before Bed by Any Harret Shawn Calfunny, Kalawa's Trip to the Motherland by Kofi Paisa, From Cocaine to Consciousness by Any Harret Shawn Calfunny, As I Learn, We All Learn by Kofi Paisa. Also, if you want fresh merch, go to our online store, Family Connect Apparel, and get all the brands. Also, get our 54 deck of quiz and educational cards, available now on KofiPaisaTV.com.
Copyright disclaimer: under Section 107 of the Copyright Act of 1976, allowance was made for fair use for purposes such as criticism, comment, news reporting, teaching, scholarship, and research. Fair use is a use permitted by copyright statute that might otherwise be infringing. ETM Hotel, Randy Shawn. Welcome to peace. My name is Shawn. I'd like to thank everybody for tuning into this episode of Science with Shawn. Looks like we're behind a few minutes, but we are in the building. Please like the show, share the show, tell a friend, tell a friend. Let's get these likes up, ladies and gentlemen. Today we're going to talk about the real messenger in RNA, understanding nature's busiest molecular machine. It's not going to be very long, but it is going to be very informative. I don't know how you are with your note keeping and things of that nature, but it's about to go down. So again, like the show, share the show, tell a friend to tell a friend. Also, for a lot of y'all that was inboxing me saying Friday, it's Friday. Make sure that you get your pre-order copy of What Sars-Cov2 Taught Me Today. Also, pick up Spearmasters, a historical survey of the minds of African warrior scholars, Volume 4 by Kofi Paisa Research Team. Peace to everybody in the actual chat. Let me see what's good. Lamar 220, Mansai was good. Enigma 9x9, 81. Benita was good. This is Benita. Culture, Coffee, Cannabis, and Enthusiasts. Peace was good, bro. Zane, what up? Nunu was good. What's going on, everybody? Yeah, it's the first of the month. You know what I'm saying? It's the first of the month. So I know some of y'all got your your Social Security checks. If you don't get them on the first, you get them on the third. But because the third is on a Sunday, you got them on the first. You feel me? I know some of y'all got your food stamps reimbursements today. You probably got thousands. Go ahead. If you got $1,000, go on and sell $250 to somebody around the corner, man. Use, you know what I'm saying, for their low. Make sure you get that, get your bills paid, get everything taken care of, and cop what Sars-Cov2 taught me and Spill Masters. You know what I'm saying? Priority number 1 and 2 on the list. Look at later this evening. Okay. The signed copy's going quick. I'm letting you know that now. So before we get going today, last night we did a Q&A session. I really thought I would have more questions and answers. I thought I would have more pushback. But it seems like the pushback is shrinking, or the people not paying attention just rather the live go off and then they want to jump in the comment section and make comments. If you pre-ordered, it will be signed. But anyway, we're going to talk about something really important and that you really don't hear a lot of. Now, you may have heard me discuss this before, and when I get into the bill, you're going to realize it. So I know that most of you are actually working. It may not be hard for you to follow along, or you may not be able to take notes or whatnot, what have you. But just know that when you come back to it, you can make it happen. All right. So again, the link to the book is in the description of the video. To both books is in the video. And I did put it in the chat for anyone that was looking for it in the chat. I'm just waiting a few more minutes before a couple of more people come in. I know I got some West Coast people who just, rubbing their eyes and brushing their teeth, hopefully brushing their teeth and killing that morning breath and getting that day started. So I'm just trying to see if any of them will pop up. And then go from there. Nope, not in person, not yet. All right, so again, like the show, share the show, tell a friend. We are live. Let me see here what I got. All right, so we're gonna go ahead and, because I don't want to drag people out. And of course, you're not gonna see any of the Mossy Warrior Clan members today. They're too busy for me. You're not gonna see any of the Kofi Pi research team members. It looked like Satepara the only one up, and he working. So he might be tuned in or something like that. Or he might be in the gym working on this crossover, trying to get ready for this whooping that he gonna get when I catch him in the street. You know what I'm saying? So let's go ahead and get started, man. I don't want to drag people out. And then, for people who may miss the beginning of the actual presentation, they can catch it on a replay. If you're not subscribed to the channel, please subscribe to this channel. Also subscribe to Science with Shawn. If you're unfamiliar with Science with Shawn, peace, Sister Safi and Mongo. What's good with y'all? What's going on? If you're unfamiliar with Science with Shawn, let me see if I got a profile up. It's in the chat. Just click on the Science with Shawn guy right there. Go to his page. Subscribe to the channel. All right. All right. So my screen is currently sharing. Again, they go to book. Yeah. Go to Science Tree, Different Branch Publishing. Get your copy of the book. Get your copy of Spill Masters. Get both. Promise you, you'll enjoy. So, all right. Let's get it going. What are ribosomes? Of course, by me. This is today's lesson. Now, notice the title in the video suggests that Well, it states that the real messenger in RNA, understanding nature's busiest molecular machine. So for most people, you probably thought that I was going in a different direction. Why would I say that ribosomes are the molecular machine? Is a molecular machine, or nature's busiest molecular machine? Well, you're about to find out. Again, the Copyright Act disclaimer under Section 107 of the Copyright Act of 1976 allowances made for fair use for purposes such as criticism, comment, news reporting, teaching, scholarship, education, and research. Fair use is a use permitted by a copyright statute that might otherwise be infringing.
Yo, talk to me, Cleveland. Have you not had your shot yet? Really? Are you serious? I know you're worried. You're thinking this is gonna be like another Tuskegee? I get it. They've been doing black people dirty for years. So why wouldn't we be concerned this time? Here's the situation, people. In Tuskegee, they did not give us the disease, but what they didn't do was give us the cure. But by not taking this vaccine, we're Tuskegeeing ourselves. The truth is, if we don't protect ourselves, nobody will. We're at over 150 million people vaccinated. And if your doctor and your mother haven't turned into zombies by now, then you won't either. The truth, man, he got his grip my head. Okay, that's it. That was no. He was like,
I'm trying to balance you so you can hold your head.
Jeff, I can balance my own head.
So today's discussion, of course, I always give you an outline. We'll have an introduction, research questions, hypothesis, definition, conclusion, and sources. In a discussion about vaccines, the lay woman or man get lost when someone is explaining the functionalities of ribosomes. Without ribosomes, our immune systems wouldn't be able to communicate properly. You may have heard me use the term each one teach one when it comes to ribosomes. And in this lesson, you'll see why I use that analogy. Here are my research questions. So what are ribosomes? How are ribosomes structured? What are the ribosomes' importance to the cell? How do ribosomes function? Where are ribosomes located? All right. I want you to think about those things because it's very important in this discussion. All right. So since the emergence of SARS-CoV-2, misinformation campaigns have dominated the airways of social media. Speculation and conspiracies have created so much confusion that our lack of understanding of basic biology and vaccine science has developed so much vaccine hesitancy that we cannot get this pandemic under control. Questions about the mRNA technology and the immune system have dominated the discussion. Throughout all the confusion, our understanding of nature's busiest molecular machine has been overlooked. This could be partly due to ignorance, but I believe it goes beyond that. Many of us have no idea what a ribosome is, where it's located, and how its functionalities. If we can't see it, we don't recognize its existence unless we are in the medical field. And this could be a huge reason why our understanding of vaccine science and the immune system is all over the place. Definitions. What are ribosomes? Well, ribosomes are non-membrane bound or import cytoplasmic organelles found in close association with endoplasmic reticulum. Look, that's big words. All right. Now, ribosomes is a cellular particle made of RNA and protein that serves as a site of a protein synthesis in the cell. Different definitions, but one is a little bit more simpler to understand. The ribosomes read the sequence of the messenger RNA or the mRNA, and using the genetic code, translate the sequence of RNA bases into a sequence of amino acids. This is just a 3D image of ribosomes. If you don't know what they look like, then this 3D image is going to skew you a little bit. However, the ribosomes, if you're really looking at this creative image, are those little circles that you see on the right-hand side of the screen, okay? Peace, Teddy. Peace from West Africa. Peace, peace. All right. Now, ribosome is a complex molecular machine found inside the living cells that produce proteins from amino acids during a process called protein synthesis or translation. The process of protein synthesis is a primary function, which is performed by all living cells. All. Ribosomes are specialized cell organelles and found in both pro and eukaryotic cells. Every living cell requires ribosomes for the production of proteins. If it lives, it has cells, it has ribosomes. This cell organelle also functions by binding to a messenger RNA and decoding the information carried by the nucleotide sequence of the mRNA. The transfer RNA or tRNAs, because if it's a transfer, then it's tRNAs, compromising amino acids enter into the ribosomes at the acceptor site. Once it gets bind up, it adds amino acids to the growing protein chain on tRNA. There's no sound in this particular 24-second video, but this is basically a cell. Inside the where RNA is harbored. As you can see in the centerpiece, not where the nucleus is outside of the nucleus. Those little circles or round balls looking things, not the blue ones, but the orange, are ribosomes. Now, the ribosome is a complex molecule made of ribosomal RNA molecules and proteins that form a factory for protein synthesis in cells. In 1955, George E. Pallet discovered ribosomes and described them as small particles in the cytoplasm that preferentially associated with the endoplasmic reticulum membrane. Along with other scientists, Pallet discovered that ribosomes perform protein synthesis in cells, and he was awarded the Nobel Prize for his work in 1974. Now, each ribosome has a large component and a small component that together form a single unit composed of several ribosomal RNA molecules and dozens of proteins. Now, the ribosome is responsible for translating encoded messengers from messenger RNA molecules to synthesize proteins from amino acids. I'm drilling this point home because if we were to flip the discussion and begin to talk about the functionality of mRNA vaccines, you're going to hear proteins a lot. You're going to hear translating or encoding, and it's going to be dealing with proteins. All right. Now, the ribosome translates each codon or a set of 3 nucleotides of the mRNA template and matches it with the appropriate amino acid in a process called translation. The amino acid is provided by a transfer molecule. Each newly translated amino acid is then added to the growing protein chain until the ribosome is complete the process of protein synthesis. All right, so again, you saw from the image above, I talked about those little dots. There's an image of what ribosomes are and how it completes protein synthesis in this instance. Now, a ribosome is a complex of RNA and proteins and is therefore known as we're just going to say ribonuclear protein. It is composed of 2 subunits, smaller and larger. Remember, smaller and larger. So what are the 2 subunits? The smaller subunit where the mRNA binds is decoded in a larger subunit. The amino acids get added. Both of the subunits contain protein and ribonucleic acid components. The two subunits are then joined to each other by interactions between the RNAs in one subunit and proteins in the other subunit. Ribosomes are located in where? Side the cytosol, found in the plant cell animal cell. The ribosome structure functions includes the following. It is located in two areas of the cytoplasm. Scattered in the cytoplasm, as you've seen from the above image, they were located in the cytoplasm and they were scattered throughout the cytoplasm. Prokaryotes have 70S ribosomes, while eukaryotes have 80S ribosomes. Around 62% of the ribosomes are comprised of RNA, while the rest is proteins. All right. Now, the structure of free and bound ribosomes is similar and is associated with protein synthesis. All cells need ribosomes to make the proteins necessary for life. I'm going to repeat that again. All cells need ribosomes to make the proteins necessary for life. These multi-component molecular machines build complex proteins by stitching building blocks together according to instructions encoded in the cell's messenger RNA. But ribosomes are themselves composed of small and large subunits, each of which is made up of ribosomal proteins and RNA. Before they can be manufactured proteins, these subunits must be manufactured themselves. It's a better view of it. 3D image.
The ribosome is a large molecular factory that translates the genetic code in messenger RNA into long chains of amino acids that fold up into a protein. The gene code is read in groups of 3 letters called a codon. Amino acids are delivered to the ribosome by transfer RNA and match to the gene code in the messenger RNA. Once gene translation is complete, the amino acid chain folds up to create a protein with a 3-dimensional shape that determines its function.
So y'all just saw ribosomes at work and the transfer RNA, which we talked about. Everything we just talked about, you just watch it in the 3D image. Now, the important ribosome functions include it assembles amino acids to form proteins that are essential to carry out cellular function. The DNA produces mRNA by the process of DNA transcription. The mRNA is synthesized in the nucleus and transported to the cytoplasm for the process of protein synthesis. The ribosomal subunits in the cytoplasm are bound around mRNA polymers. The tRNA, which is the transfer RNA, then synthesizes the proteins. The proteins synthesized in the cytoplasm are utilized in the cytoplasm itself. The proteins synthesized by the bound ribosomes are transported outside the cell. Ribosomes churn out every single protein a cell needs to survive and are incredibly complicated machines. In fact, it took decades of research to figure out exactly how they work. So we're going back to the Nobel Peace Prize winner, which was a chemist, which was awarded in 3 scientists, actually. And then you have Rameskraman, I can't say their name, Stitz, and Yonath for their work on understanding the structure and the function of ribosomes. Now, while we now know that ribosomes look slightly different in different organisms, all ribosomes perform a universal set of critical functions for building proteins. Remember, the key phrase here is proteins, building proteins, developing. They all move along an mRNA blueprint. Take an amino acid and attach it to a growing chain of amino acids that ultimately becomes proteins. Ribosomes collect and link amino acids together. Look at the image above. mRNA is a chain of chemicals called nucleotides, which a ribosome reads in group of 3. Every set of 3 nucleotides is called a codon. Contains the blueprint for specific amino acids. As you can see in the image, there's a square at the very bottom. You probably can't see my mouse, but at the bottom of the image, of the Pac-Man looking image, you see something that says codon, every set of 3. You see orange, red, and this aqua bluish color. Every set of 3 that's like that, codon. A ribosome doing its job looks a bit like a Pac-Man making its way along a string of cookies. For every set of 3 mRNA nucleotides, the ribosome collects the corresponding amino acids and attaches it to a growing string of amino acids. Ribosomes have an essential support workers called transfer RNA that bring them the right amino acid each step of the way. So the tRNA is responsible for bringing forth the right amino acids every step of the way. When Pac-Man opens his mouth over an mRNA codon, the transfer RNA enters the mouth, carrying the right amino acids. As the ribosome collects a new amino acid, it attaches this amino acid to a chain of amino acids. It just has just a piece together by performing a chemical reaction. As it moves further along the mRNA, this chain grows. Once a ribosome has finished reading a blueprint, it releases the protein into the cell. That ribosomes is then ready to repeat the process. So this is a repeatedly ongoing process. So if I play back the video we just saw, you're going, that noise and all of that that you see transpire or hear transpiring, it's going to do that and just keep doing that and just keep doing that. Now this is taking place throughout your entire body, whether you're a plant or an mammalia. Viruses use our ribosomes to make their own proteins. Think about that. So we're already doing one thing ourselves, and then we encounter a foreign pathogen, and the foreign pathogen uses our ribosomes to make their own proteins because ribosomes are doing their job by developing proteins. So the viruses come into contact with our ribosomes, and then they're like, hey, I need you to make me some proteins since you already know how to make the proteins. And then I'm going to take advantage of you. And then I'm going to have you replicate this throughout your body. Now you are infected with a virus and you're going to spread my disease. So let's learn more. It says the universal use of DNA, mRNA, and amino acids is what makes it possible for viruses to exist. I'm going to say that again so people will understand. The universal use of DNA and mRNA and amino acids is what make it possible for viruses to exist. This is because a virus on its own is not a living organism. Instead, it is a blob of fats. Listen to this, y'all. Viruses are a blob of fats and proteins that enters the cells of other organisms and use their factories to replicate it. A virus also carries with it an instruction manual or blueprint to tell a cell exactly how to build more of it. The parts of a virus that our immune system sees, the antigens, are typically whatever encapsulated the rest of the fats, proteins, and genetic material inside of it. I'm going to run that back too, because it sounds like when we're trying to create a defensive mechanism to fight the foreign pathogen or this antigen or this virus or whatever I'm just going to stick it pathogen. When we're trying to fight it, We need to know how it behaves. So the parts of a virus that our immune system sees are typically whatever encapsulates the rest of the fats, proteins, and genetic material inside. In the case of SARS-CoV-2, one important surface molecule is called the spike protein, named for the fact that it is physically juts out from the rest of the virus. The spike protein plays an essential role in SARS-CoV-2 binding to a host cell. It is considered a very important antigen that can be exploited for vaccine design. The idea behind vaccines is that exposing our bodies to some of these antigens mimics the virus enough for our bodies to mount an immune response, but without making us sick from the actual pathogen. Conventional vaccines have achieved this either by using inactivated viruses or engineering other harmless viruses to encode some of the pathogenic viruses antigens in their blueprint, i.e. second generation vaccines, first and second generation vaccines. Now, our understanding of ribosomes and how they build proteins has enabled us to pursue an emerging vaccine technology that would bypass the need for producing large quantities of the virus and mRNA vaccines. Voila. Our understanding of ribosomes is the reason why we have today an emerging technology called mRNA vaccines that help us, because we no longer need what? The virus. So we don't have to weaken it, and it doesn't take years to weaken it. And now we can put this in play with our understanding of ribosomes, the process that sped up the vaccines. This understanding is instrumental in how that process, warp speed, could come into play.
This is SARS-CoV-2. It belongs to the family of coronaviruses named for the crown-like spikes on their surfaces. SARS-CoV-2 can cause COVID-19, a contagious viral infection that attacks primarily your throat and lungs. What actually happens in your body when you contract the coronavirus? What exactly causes your body to develop pneumonia? And how would a vaccine work? The coronavirus must infect living cells in order to reproduce. Let's have a closer look. Inside the virus, genetic material contains the information to make more copies of itself. A protein shell provides a hard protective enclosure for the genetic material as the virus travels between the people it infects. An outer envelope allows the virus to infect cells by merging with the cell's outer membrane. Projecting from the envelope are spikes of protein molecules. Both a typical influenza virus and the new coronavirus use their spikes like a key to get inside a cell in your body, where it takes over the cell's internal machinery, repurposing it to build the components of new viruses. When an infected person talks, coughs, or sneezes, droplets carrying the virus may land in your mouth or nose and then move into your lungs. Once inside your body, the virus comes in contact with cells in your throat, nose, or lungs. One spike on the virus inserts into a receptor molecule on your healthy cell membrane like a key in a lock. This action allows the virus to get inside your cell. A typical flu virus would travel inside a sac made from your cell membrane to your cell's nucleus that houses all its genetic material. The coronavirus, on the other hand, doesn't need to enter the host cell nucleus. It can directly access parts of the host cell called ribosomes. Ribosomes use genetic information from the virus to make viral proteins, such as the spikes on the virus's surface. A packaging structure in your cell then carries the spikes in vesicles which merge with your cell's outer layer, the cell membrane. All the parts needed to create a new virus gather just beneath your cell's membrane. Then, a new virus begins to bud off from the cell's membrane. Now, with the virus spreading in your body, how can you develop pneumonia symptoms? For this, we'll have to look into your lungs. Each lung has separate sections called lobes. Normally, as you breathe, air moves freely through your trachea or windpipe, then through large tubes called bronchi, through smaller tubes called bronchioles, and finally into tiny sacs called alveoli. Your airways and alveoli are flexible and springy. When you breathe in, each air sac inflates like a small balloon. And when you exhale, the sacs deflate. Small blood vessels called capillaries surround your alveoli. Oxygen from the air you breathe passes into your capillaries, and then carbon dioxide from your body passes out of your capillaries into your alveoli so that your lungs can get rid of it when you exhale. Your airways catch most germs in the mucus that lines your trachea, bronchi, and bronchioles. In a healthy body, hair-like cilia lining the tubes constantly push the mucus and germs out of your airways, where you might expel them by coughing. Normally, cells of your immune system attack viruses and germs that make it past your mucus and cilia and enter your alveoli. However, if your immune system is weakened, like in the case of a coronavirus infection, the virus can overwhelm your immune cells, and your bronchioles and alveoli become inflamed as your immune system attacks the multiplying viruses. The inflammation can cause your alveoli to fill with fluid, making it difficult for your body to get the oxygen it needs. You could develop lobar pneumonia, where one lobe of your lungs is affected, or you could have bronchopneumonia that affects many areas of both lungs. Pneumonia may cause difficulty breathing, chest pain, coughing, fever and chills, confusion, headache, muscle pain, and fatigue. It can also lead to more serious complications. Respiratory failure occurs when your breathing becomes so difficult that you need a machine called a ventilator to help you breathe. These are the machines that save lives and that medical device companies currently ramp up production for. Whether you would develop these symptoms depends on a lot of factors, such as your age and whether you already have an existing condition. While this all sounds scary, the push to develop a coronavirus vaccine is moving at high speed. Studies of other coronaviruses led most researchers to assume that people who have recovered from a Sars-Cov2 infection could be protected from reinfection for a period of time. But that assumption needs to be backed by empirical evidence, and some studies suggest otherwise. There are several different approaches for a potential vaccine against the coronavirus. The basic idea is that you would get a shot that contains faint versions of the virus. The vaccine would expose your body to a version of the virus that is too weak to cause infection, but just strong enough to stimulate an immune response. Within a few weeks, cells in your immune system would make markers called antibodies, which would be specific for only the coronavirus, or specifically its spike protein. Antibodies then attach to the virus and prevent it from attaching to your cells. Your immune system then responds to signals from the antibodies by consuming and destroying the clumps of viruses. If you then catch the real virus at a later stage, your body would recognize it and destroy it. In other words, your immune system is now primed. Collecting evidence on whether this will be possible, safe, and effective is part of what's taking researchers so long to develop a vaccine. It's a race against time to develop a vaccine amid a pandemic. Each step in vaccine development usually takes months, if not years. An Ebola vaccine broke records by being ready in 5 years. The hope here is to develop one for the new coronavirus in a record-breaking 12 to 18 months. While all of this will take time, stay home if you can, to protect the most vulnerable. And don't forget to wash your hands for at least 20 seconds, and as often as possible. This video was a collaboration.
I had to take that back just to bring y'all forward. So the conclusion is, Ribosomes is a complex molecule made of ribosomal RNA molecules and proteins that form a factory for protein synthesis in cells. Ribosomes are important because cells need them to make proteins necessary for life. Understanding ribosomes helps mRNA vaccines become what they are today. Ribosomes are structured to read, research, and teach. Knowing how ribosomes function have been the missing key in numerous discussions had on all social media platforms. Now that we have some understanding of ribosomes and its importance, maybe we can be mini ribosomes in our communities by making the proteins that leak out of the cell to make the spike protein, to make the spike against mis and disinformation surrounding the topic of vaccines. Here are my sources. You can pause the video, screenshot it, go from there. But they were on each slide. Don't forget to get Spear Masters Historical Survey of the Minds of African Warrior Scholars, Volume 4, out now. The description has the link. Pre-order your copy of What SARS-CoV-2 Taught Me today. Get your copy today. There's only so many signed copies that will go out. And as of right now, there's been an influx of purchased, pre-orders that have been put in. So I'm thankful for the people who've pre-ordered, and they will all be signed and sent out to you for sure. And there's only I'm gonna say it again, there's only a certain amount of those copies that will be signed and sent out. Straight up. So for those of you that I see in the chat now, I noticed that a lot of people have just came in and missed the actual onset of this particular presentation. Today's topic, and I will address it again if you see it, is the real messenger in mRNA, understanding nature's busiest molecular machine. And that is the ribosomes. Ribosomes are the busiest molecular machine at work. It's constant, it's repetitive, and understanding ribosomes help them understand that they can make a vaccine that would prevent the spread of infectious disease, hospitalization, and death, because they understand how ribosomes behave and they make that key central protein. So using that knowledge brought forth warp speed record vaccines and other things. That's not the only piece. There were several other instances that helped bring forth. But in this instance, the one that's left out the most is the ribosomes. They're instrumental, very instrumental, because it's teaching, programming, aligning, assessing, it's doing all the transferring, it's doing all of those things. It's taking the amino acids and lining it up. Come on, man, it's working hard to do all of those things. And then then that understanding led to the fact that, hey, wait, viruses use our ribosomes to impact us or infect us internally, because it knows, it doesn't know, but you know what I mean? When it enters, it's similar. It enters the area, the cell, right? It gets there. You just saw a great example of that, of how it enters, how the encoding process takes place, how it's transcribed, how it consumes, how it manipulates inside of the body. Then it gets to these other areas, whether you have inhaled it, whether you have swallowed it, wherever this virus may be. It's not just the coronavirus, it's all viruses, how all of them behave. So once you have had a vaccine that would prevent all of those things from transpiring, then you reduce the spread of infection, which reduces the risk of the severity of the infection or the virus that has encountered the body, and limits the spread of the infectious disease. And then you have what you have today. 99% of hospitalizations and deaths are not in the vaccinated group. The unvaccinated are making up everything. The unvaccinated are making up everything. They hold the highest numbers. We have 0.002% death rate in the vaccinated. You got 0.002 in the, or something like that, in the hospitalizations, making a very small portion. So if we have 2,000 people dying a day, it's in the unvaccinated group. Straight up and down. Look who found us, y'all. I swear this bot done found us again. All right. So here's the thing about all of this. I don't even know why PCR tests are being, we're talking about ribosomes. So for those of you who just joined, if you have any questions, comments, or anything like that pertaining to the presentation, we can deal with it. If not, you know what I mean, I'll wind down and we can transfer this into a different build on Kofi Pie research team, and we can go from there. We want to bring some authenticity, some decorum to the conversation, and not a bunch of pseudoscience or speculation. So give me just a second. I want to check something out. I want to check. Yeah, it's blocked. That's a bot, to be honest, y'all. It's not a real person. They have those bots now, since they can't make YouTube videos because YouTube kicking them off. The recent detection of SARS-CoV-2 variants, the UK and South. Oh, this is old information. This is old information. It's beat up too. The current evidence based on mRNA vaccines is made up entirely of small early stage trials. This is, yeah, you gotta, if you're using, all right, so this is good. This is the reason why my book is important to everybody. Look at the trolls, y'all. Look at the trolls, y'all. They coming, they out. Another troll pops up. Call me an idiot and everything. Them Autobots. So let's just keep it a buck. No, it's not a real person. Don't even waste your time. It's not a real person. They're Autobots. Anytime someone's having a conversation about a certain topic, the Autobots show up. Is it? It's it. So Joseph McCullough is in my book. So I really don't want to do too much talking about him. He's in chapter like 5, I think. He makes millions of dollars off of misinforming people. And I don't elaborate too much on Joseph, but you know what I'm saying? The troll put that in there, so let's deal with it. And as you can see, aligned with Robert F. Kennedy. So McCullough is an American alternative medicine proponent. He's an osteopathic physician. Remember, we've dealt with this before. Osteopathic physician is a medical degree offered by medical schools in the U.S. A DO graduate may become licensed as a physician. DOs have full practice rights in all 50 states as of 2021. There were more than 168,000 of these osteopathic physicians. Okay. Now, on his website, McCullough and colleagues advocate a number of unproven alternative health notions, including homeopathic oppositions to vaccinations. Now, these positions have faced persistent criticism. Mercola is a member of several alternative medicine organizations. All right, you see his group right here. And there's another one. So he claimed, listen, Mercola's medical claims have been criticized by medical, scientific, and regulatory and business communities. Has been. The dude shows up on watchdog sites like QuackWatch. He's a member of QuackWatch. You can deal with him if you want to. I mean, I really don't want to deal with him, but he's already spewed out a bunch of misinformation. So when you see Gloria showing up, the Autobot Gloria Miller, who acts as if they are not an Autobot, show up and post certain things, they're posting the pseudoscientific claims made by this person regarding COVID-19 at heart. It's copy and paste. It's the same thing. So if you don't believe me, some of the messages that were dropped in here regarding some of the claims is crazy. And then there's another quacked out doctor she used that really is not an epidemiologist, immunologist, or virologist that actually does that. Look, he made a claiming cancer risk arise from mobile phone radiation. This is one of the claims he made. Claims that many commercial brands of sunscreen increase rather than decrease the likelihood of contracting skin cancer. He claims that microwaving food alters its chemistry. He's an advocate of labeling health and genetically modified food, as well as for the elimination entirely from the market. He recommends dietary recommendations on food consumptions that often put him at odds with mainstream dietary advice. He claimed that inhaling 0.5 to 3% of hydrogen peroxide solution used in nebulizer could prevent or cure COVID. So he wants you to use a nebulizer, and he wants you to consume the chemical compound of hydrogen peroxide, 0.0 to 3%. He gonna kill somebody. But that's Mercola. Now, there's other claims that he's used that you'll see also in the book. And it goes a while with that. Yeah, they pseudobots for real. Yeah, and yes, they are trolls. So again, you can pre-order your copy of What SARS-CoV-2 Taught Me. We have a limited amount of books that will be signed in the pre-order group. You will have your books before the official release. There's already been a growing list of people who've already purchased. I'm pretty sure by the end of today, not on this channel. This channel is ran by a team. This is not my channel. And we don't hand out the wrenches. Only to the Masu Warrior Clan members. Sorry. The list is growing, has been growing. We've been getting emails and updates. So the book can be purchased in the UK. The book can be purchased all over the world. So yeah, this won't be limited to the United States. I know Fitz was trying to figure out, could he get access to the book? Yes, he will have access to the book. He can order the book and get the book sent to him. Now, he wouldn't necessarily go to Same Tree, Different Branch to order the book. Fitz, I am going to have the linkage information for you to be able to get your book where you need to get your book at. And shortly. So you know, when it releases. Nah, I'm not wasting time for cracks. So again, I don't want to draw this particular conversation out too far. I do want to thank everybody for tuning in. I may turn around and go back live, but and do a second show from Kofi Paisai research team chat, just a little Q&A or bill like that, and then we can continue the conversation or get into some gangster stuff. So again, I'd like to thank everybody for tuning in. Also, while you're purchasing Spill Masters and pre-ordering what SARS-CoV-2 taught me, go and pick up Kofi's book, Beautiful Lessons of Kimoyo. Also on Same Tree, Different Branch. And if you hadn't got all the other Spill books, cop those as well. All right, so I still see that we had I was 40 people in the building. I appreciate everybody for tuning in to this episode of Science with Shawn. Today's discussion was in regard to the real messenger in RNA, understanding nature's busiest molecular machine, which if you catch the replay, you'll understand why it's named that. I appreciate everybody for tuning in. I am getting ready to set up a second show. I want to keep this digestible for people that is looking to learn, whose attention span is within that hour range, and that can be useful for them. And I want them to get as much out of this as possible. So I probably will stay on Amasi as a follow-up discussion and show, and we can get into some a Cell article and document that has been published recently and see what that document is saying and comb through it and have another lesson in mRNA vaccine technology. On that note, pick up your copy of Spill Masters today, Same Tree, Different Branch, and across all media, all publishing sites. And then pre-order your copy of What SARS-CoV-2 Taught Me, Same Tree, Different Branch. Like I said, there's a limited amount of signed copies that will be going out to people. So it's on a first come, first serve. Get yours now. Do not wait. I don't know what's going to happen by in the next couple of hours. I don't know about the next, by the end of the day. So once that number has been met, then everything else is going to be a shipped copy. Because, I can't write 100, 200, 300. I don't think I'm going to be writing 300 people names. I'm not going to be writing 1,000 names. I don't even think I'm going to write more than 50. So, you know what I'm saying? I want to get those out there to the hands of the people who, actually support the works and things of that nature. And if you're interested in knowing more about what SARS-CoV-2 taught me, then this will be the book for you. The link is in the description to both books. Shimon Hotel, and we'll be right back live. I'm not going to switch to the Kofi. I'm going to stay right here on the Masi. We'll be right back live on the Masi Warrior Clan channel going into more mRNA technology. Peace.